Good day to you. Density calculations. That's what we're going to do today. But it is part of the molar mass, molar volume, number of atoms, and all of that included with the density calculation that we're going to use. Now, remember that molar volume, if this is the density formula, the mass over volume, if this is gas, this is the compound that we are using or element we are using is gas, we can use the 22.4 liter per mole at STP, but only applies to gaseous compound or elements, okay? It doesn't apply to liquid or solid. So be aware of that. So first question, what is the density of F2 gas? That's the fluorine gas at STP. And the molar mass for the fluorine is 19. So we know that, so F2 molar mass would be 2 times 19, which is 38.0 gram. And once we have that at STP, so the density is equal to mass over the volume, that would be 38.0 gram. And because it's gas, we can use this now. That's 22.4 liter. Okay, simple as that. And when you do the number, you will end up getting 1.70 gram approximately per liter. Okay, let's look at another example. So here's another example. We have 50-liter bulb has 4.91 gram of gas at STP. Again, it's gas. What is the molar mass of the gas? So this is very interesting, but it's straightforward again. Now, the density, you can easily use the density in here, is giving you the volume. So density is equal to mass again. In this case is the molar volume, and you can use that, and then later on we can change it to the value that we want. The first thing is, as of now, we have 4.91 gram divided by the volume, which is 50 liter. First, let's find out what is the density, and this would be 1.964 gram per liter, right? But then we want to get the molar mass. To get the molar mass from the density, so we're going to start with 1.964 gram per liter times, and in this case now we're going to use the liters on top, so that's 22.4 liter, and that's 1 mole. Now remember, gram per mole, that will get you the molar mass, and you just multiply through and you'll end up getting 44.0 gram per mole. Okay, that would be the molar mass. We use the density to go back and use the value at STP, 22.4 liter per mole, and then get the value. All right, let's look at another question. Here it is. How many atoms of aluminum are in 100 milliliter of aluminum oxide? This is aluminum trioxide. All right, so let's figure that out. This is how many atoms is in there. So first figure out, we have 2 aluminum and 3 oxygen. When you add them all up, we'll end up getting 102 grams for the molar mass. So now that we have the molar mass, we're going to go ahead with the density that's given to us in the question. We're going to write up the form, and we're going to use the density. First, we're going to start with the 100 milliliter times, and now we're going to use the density. That's 1 milliliter. We have 3.97 gram of aluminum oxide, and then multiply that by, and then we're going to go through the mole. So the gram is on top, is gram on the bottom, 1 mole is on top, and that is 102. That's the molar mass. And then asking for number of atoms. So in 1 mole, we have 6.02 times to the 23, 10 to the 23 molecules for every mole. And also we have 2 aluminum atoms, which is given right there, 2 aluminum atoms for 1 molecule of Al₂O₃. So now we have everything set up, and notice that we can go ahead and divide the units. Milliliters divided by milliliters, gone. Gram, gone. Mole and mole gone. Molecules and molecules gone. The only thing that is left is atoms, and that's what we want, atoms. And then when we do all the math at the end, we will get 4.69 times 10 to the power of 24 number of atoms in 100 milliliter of Al₂O₃, and it seems that that makes sense. Okay, let's look at another question. Well, this is a straightforward question. It's a gaseous compound, so the density is equal to mass, and this is going to be molar mass over the volume as molar volume. And here we know that the molar mass of CO2 will be 44 grams. Okay, that's, remember, that's 12, 1C, which is 12, and 2 oxygen, which is 32. Okay, and then we just punch numbers in. So 44.0 gram divided by 22.4 liter. And then when you do the math, you will get 1.96 gram per liter. That's the density. Okay, very good. And last question. So we have this CS2 is a liquid and has a density of 1.62 gram per milliliter. What volume is occupied by 4.5 times 10 to the 22 molecules carbon disulfide? Okay, molar mass of this CS2 is 76.2, 1 carbon, 2 sulfur. Okay, so you just multiply and then add and multiply. You're going to get that. And then you got to set this up one step at a time, starting with the molecules. Okay, so that's what we're going to do, the startup. So this is the first part, the number of molecules, and in 1 mole we have Avogadro number 6.02 times 10 to the 23 molecules, and then we have to change that again and then get rid of the moles. So 1 mole, and then we want to include the gram in here. So this is what we're going to do. And here it is. We're going to use the molar mass, right? And then the last thing that we're going to use the density here, right? So we want to have the volume at the end. So this will end up being multiply, and then we have a gram at the bottom, milliliter on top, 1 milliliter, 1.26 gram. All right, when you do all the multiplication and everything, at the end you'll get 4.52 milliliter. That's the volume of the liquid with that density, and it has got that many molecules. Perfect. Make sure you take the quiz that is in the description or in the pinned comment below. Make sure you check the answers after you give it a try, and also go back and review all other lessons regarding and related to this topic. Is all related. There were 4, 5, 6 different calculations that you have to be able to do, and make sure you practice. Okay, until next time, and make sure you check the next video. Okay, be well.